Hi students, welcome to physics classes. Now we are discussing NCERT questions, solutions for NCERT questions from motion in a straight line. Now the question number 12. Now here a ball is dropped from a height 90 meters. Ball is dropped from a height 90 meters on a floor. At each collision with the floor, the ball loses 1/10 of its speed. For every collision, it is losing its speed. That is how much? 1/10 of its speed. Now plot the speed time graph of its motion between t equal to 0 to 12 seconds. Between t equal to 0 to 12 seconds, we should draw the graph for speed time. Okay. Now here a ball is dropped from a height. So h equal to 90 meters and it is dropped. So initial velocity equal to 0 and time equal to 0. Initial velocity and time equal to 0. Now the ball is coming down. So g value becomes 9.8 meter per second square. Velocity after reaching the ground. First time when it is falling ground, what is its velocity? So we can take v square minus u square equal to 2gh. As u is 0, v square equal to 2 into 9.8 into h 90. Then if you do simplification, you will get v equal to square root of 2 into 9.8 into 90. Then it is equal to v equal to 42 meter per seconds. Now v equal to 42 meter per seconds. Now what is the time it reaches the ground? To find time, we will use the second equation of motion, h equal to half gt square. As u is 0, ut becomes 0, then we will get h equal to half gt square. From that we can write t equal to 2h by g under root. Then 2 into 90 divided by 9.8. Then if you do simplification, we'll get nearly 4.28 seconds. So in the second situation, velocity equal to 42 meter per seconds and the time equal to 4.28 seconds. So here first point u equal to 0, t equal to 0. Next v equal to 42, t equal to 4.28 seconds. Now v equal to 42 meter per second and t equal to 4.28 seconds. Now collision takes place. In this situation, it loses 1/10 of its speed. It loses 1/10 of its speed. Now here it is having 42 meter per seconds. How much it will lose? We will calculate now. Now 1/10 of its speed it is losing. Means we will take it is velocity v2 equal to 1/10 of speed means we can take 10%. So v minus 1/10 of v. V minus 1/10 of speed, 1/10 of v. 1/10 of v losing, so minus. Then it becomes 9v by 10. As we have here v equal to 42 meter per seconds. Then if you substitute here v2 equal to 9 into 42 by 10. 37.8 meter per second. 37.8 meter per second. Now with this speed it is rising up. With this speed it is rising up. Now v2 is 37.8 meter per seconds. With this speed it is rising up. We will calculate here how much height it can rise with this speed. With this initial speed, how much height it can rise, we will calculate. So if it is taken as initial speed, it can rise as up some height, then the final speed becomes 0. Final speed equal to 0. Then we will write v square minus u square equal to 2g h. v0 then minus u square, u mean 37.8 whole square equal to 2 into 9.8 into h dash I am taking. Then g value, as it is going up, g value will be minus, so minus gets cancelled. Then h dash equal to, we will get 72.9 meters. If you do simplification, we will get this much height. Secondary bounds. Now, how much time it will take to go there? How much time? Again, we will use the same formula for calculating time. Initially, we got time t1 equal to 4.28 seconds. Now, we will take it is t2. Now, we will take it is t2 equal to 2h square root of 2h dash by g. Then 2 into h 72.9 by g 9.8 square root of. Now if you do simplification, here we will get 3.8 seconds. 3.8 seconds. Now here, what is initial velocity in this situation? 37.8 meter per second. Now here velocity is 37.8 meter per second and time taken is 3.85 seconds. 3.85 seconds nearly. Now the total time is initially 4.28 seconds and now 3.85 seconds. Then if you do total, nearly 8.13 seconds. Now here it is the initial velocity of second case. Initial velocity in the second case. With this initial velocity, ball raises 72.9 meters and time taken is 3.85 seconds. Time taken is 3.85 seconds. Now, with this, in this time, ball raises to 72.9 meters and again it will fall down. No, to fall down, time taken is again 3.85 seconds. In the same time, time of ascent equal to time of descent. So to rise up, to go upward, time taken is 3.85 and it will fall down in a time 3.85 seconds. And while reaching the ground, its velocity becomes 37.8 meter per second. With this initial velocity, it raised up and again it will fall down. Final velocity becomes same 37.8 meter per seconds. Now after falling, it will rebounces. At that time, 1/10 of its velocity will be reduces. Then we have taken v minus v by 10. V minus v by 10. Then how much it is? 37.8 minus 37.8 by 10. Then it is nearly equal to 34.02 meter per seconds. 34.02 meter per seconds. With this velocity, it will rises up. With this velocity, it will rises up. Now here, with this velocity, it rises up. Then time taken is already 8.13 seconds. Now to fall down, it will take again 3.85 seconds. So 8.13 second plus 3.85 seconds. Total time equal to 11.98 seconds. So it is nearly equal to 12 seconds. In the question they asked between 0 to 12 seconds. Between 0 to 12 seconds. So we got 12 seconds. Next further no need to calculate. Now what are the points we got that we will write see here. Now see, initially in first case velocity equal to 0, time equal to 0. Now it is dropped from a height, then velocity becomes 42 meter per second and time taken is 4.28 seconds. Then after reaching the ground, there is a 10% loss of its speed, 10% loss of its speed, then it becomes 37.8 meter per seconds. Now again it raises with this speed, it raises up, then time becomes 8.13 seconds. Now in 37.8 meter per second it will reaches the ground, and again 10% loss, 34.2 meter per seconds. Time taken is 11.98 seconds. Now we will draw the graph between these values. Now we'll see here, time is taken on x-axis, speed is taken on y-axis. In a graph, speed on y-axis, time is taken on x-axis. Now initially its speed is 0 and time is 0, so this is the point. And as we have seen, time increased to first case 4.28, next 8.13, next 11.98. Speed is increased to first case 42 we have, next 37.8, next 34.202. Whatever the we have the values that I have taken on the y-axis. Now initially speed is 0, time also 0. It is falling from certain height, speed is gradually increases up to 42 meter per second, and it bounces back. When it is bouncing, 10% of speed will be reduced, 1/10 of speed is reduced, then it becomes 37.8 meter per second. With this speed it raises up, with this speed it raises up. When it is going up, slowly its speed will be reduced to 0 in a time 8.137. Time taken to fall is 4.28. Time taken to raise, total time taken to raise maximum height is 8.137. Again it falls down. Here it will falls down. When it is falling down, speed is increased to initial case. When it is raising up, its speed is 37.8 meter per second. Now gradually it becomes 0 when it reaches to maximum height. When it reaches to maximum height. After reaching maximum height, it will fall down. When it is coming down, again it will have the same speed. Again it will have the same speed. And after getting the falling on the ground, it loses 10% of its speed. So when it is loses 10% of speed is, it becomes 34.02 and time taken is 11.98 seconds. So between 0 to 12 seconds, this is the graph. Initially falling down and loses its speed, raises up and falls down, loses its speed. I hope it is very clear for everyone. Thank you for watching. Please subscribe for more updates.